Math 265A, Cuesta College, I'm Joe Vasta, and we are covering Bug 12. So before we get into Bug 12, we are going to answer this question. We haven't done anything like it. We are given the derivative, which is x to the fourth. We are asked to find the original function f. Now, this is new. We are going into a new area of calculus. We are now going from the derivative back to the original function, and sometimes that is called the antiderivative. So let's just try to guess this one here. And I know that's kind of a bad way to do it, but we'll see what we can do. Well, we know, like, if we take the derivative of like x to the eighth, and we take its derivative, it gives us 8x to the seventh. So we're kind of going back, and when we go backwards with an antiderivative, it looks like the exponent's going to be one more than it used to be. So if we are at the derivative here, the exponent's going to be to the fifth. Now, we also have the issue of that number that pops up or does something. And so the best way to now finish this is to take the derivative of x to the fifth. And what do we end up getting? We end up getting 5x to the fourth, not x to the fourth. So you need to compensate for that by putting a 5 on the bottom. Because watch this, when you take the derivative of this original function now, you get 5x to the fourth over 5, and the 5's cancel. That gives you an x to the fourth. So find the function. We did. Now here's the deal. I probably should not have boxed it all the way. So let me go ahead and unbox it. And you're probably thinking, well, what happened, Joe? Didn't we find it? Well, yes, you take this guy's derivative, you end up getting x to the fourth. But also, if you take the derivative of x to the fifth over 5 plus 1, you take that derivative, it is x to the fourth. And you take the derivative of x to the fifth over 5 minus 27, you get x to the fourth. And you take the derivative of x to the fifth over 5 minus pi over 3. You know, you have any constant that's added to this, it will still be a legitimate answer. So here's the deal with antiderivatives. When they ask you to take the antiderivative, it's going to be this part here plus a constant. And so that's a weird looking box, but there is the original function f. It is x to the fifth over 5 plus c. This right here is called the antiderivative. Why don't we go ahead and do another one? So problem number 2, let the derivative equal x to the 10th. Find, I'll put it right here, f of x. We kind of run out of room here, so I'll put the answer below here. F of x is, oh, what did I just do? Okay, so this is x to the 10th. I put 10 to the 10th. I'm going to roll here today. Oh, what's happening to the whiteout? So this is x to the 10th. Let's get that out. Oh man, what a mess. Okay, so the derivative is x to the 10th. Find the original function. Well, look at the pattern here. It almost seems like you added 1 to the exponent, so that became a 5, and then you put a 5 down there. Well, that's what we're going to do to this. We are going to add 1 to that exponent of 10, so that's going to give me an 11, and put an 11 on the bottom. Now when you go to take the derivative, you get 11x to the 10th over 11. So the 11s cancel, so you end up getting that x to the 10th, which I'm annoyed at because of that whiteout. Now we don't want to box our answer, and so we put a plus c. And so there is the function, which brings us to a rule for antiderivatives. The rule for antiderivatives, you have f prime equaling x to the n, where n actually really is almost all real numbers here. We are going to say that the original function, the antiderivative, is going to be, maybe you should pause the video and then see if you can write the formula. Okay, it's going to be x to the n plus 1 all over n plus 1. And then we put a plus c. So here is the rule that we use for antiderivatives. And I said it works for all real numbers n, except possibly, well, maybe you can think of the number that's not going to work for this. Maybe a negative 1. Because what happens when negative 1's right there? You end up having some problems. So we're going to find out, you know, in the next section that we do. I think it's 4.9 or something. What happens if n is negative 1? We're not going to worry about that now because we are worrying about just this new skill. Let's go ahead and do another problem. Okay, so we have that rule down. This is going to be problem number 3. We have f prime. We have the derivative this time is 2x. Now, this is the same as, oh, look, I'm giving you a velocity function. I want you to tell me what the position function is. So that's where we're going with this. This is why it's called bug 12, because we'll start talking about those bugs. Okay, so the original function, or the antiderivative of this guy here, we are going to go like this. We're going to say, well, we have a 2 in front of it, so, you know, maybe that's a little more confusing. But I'm still going to go ahead and put an x, and the power on that is 1, so I'm going to put a 2 there. This is all over 2. And when you have a constant in front, it stays out in front. Just like with the derivative, the antiderivative works the same. So the 2's are going to cancel, and you're going to get f of x equals x squared, and don't forget the plus c. I'll put it up here as well. And so there is the antiderivative. Now the antiderivative, we said, is infinitely many functions. I should do this because this is a calculus class. I'm going to show you what those guys look like. Those guys look like parabolas. Look, if c, okay, so let me write that up here. F of x equals x squared plus c. So c is 0, you've got that parabola where the vertex is at 0, 0, and if c is 2, you've got that one. And I only put a few family members that kind of got cut off there. All those guys happen to be the antiderivative of the original guy 2x. And it kind of makes sense because if you analyze the slope of this guy right here, the slope at x equals 0, and the slope at x equals 1, and the slope at x equals 2, that's the same as analyzing the slope of this guy. This is going to have the same slope function, this guy up here, as the guy who has the vertex at 0, 0. So all these people, by a shift of up or down, have the same slope, and that slope happens to be the original function. Here's the slope function. Not to be confused with Obadiah's slope from the Barchester Chronicles. Some of you are like, what? Well, maybe you should read or watch the movie, The Barchester Chronicles. There is quite a character named Obadiah Slope, who his original name was Obadiah Slop, and he changed it. See, so there's some homework. Go watch the Barchester Chronicles. Let's go ahead and do another problem. problem number 4. We just want to make sure we feel comfortable with this. So problem number 4 says f prime of x equals x cubed minus 7x squared plus 4x plus 5. We are to find f of x, or find the antiderivative. So that's really the same question. So f of x is, I'm going to go ahead and do this power rule that we wrote down. We write this as x to the, we add 1, 4, and then put it over 4. The next term is going to be minus 7, and then I'm going to go x, add 1 to that power, which is 2 plus 1 is 3, and put it over 3. And then we have 4, the power on that is a 1, so add 1 to that, and let's put that up there in red. So that gives me a 2, and then we divide by 2. And the antiderivative of a constant is not going to be 0, like the derivative of a constant is 0, but let's go ahead and look at this. This is really x to the 0. So when you are taking the antiderivative of a constant like 5, we could write like this. We could say 5x to the 1, because we added 1 to that exponent. This is all over 1. You're going to get used to taking the antiderivative of a constant, and you probably won't write, x to the 1 over 1 when you do a few of these problems. And then we have our constant. Okay, that's always going to be the case. So let's go ahead and clean this up a little. So f of x equals x to the 4th over 4. You can write that as 1/4 x to the 4th if you'd like. This is minus 7x cubed over 3 plus 2x squared plus 5x plus c. There's the antiderivative. And you can go to take the derivative of this to check your answer. I mean, look at this, 4x cubed over 4, so that's x cubed, and then this 3 jumps down, cancels with that 3, so minus 7x squared, and then plus 4x, and then plus 5, and then the derivative of c is 0, so it's out of there. So that's what you can do with antiderivatives. You can check your answer by taking the derivative really quickly, and I didn't even write anything down when I did that. Okay, so what does this have to do with what we're doing? I'm trying to find one of my bugs here. Has everything to do with the bug. Okay, so we have a bug which is moving on a number line. We've been talking about this for a long time now, maybe since the first week or so. At time t seconds, his position is s, feet from the origin, his velocity is v, and his acceleration is a. In the next section, we're going to visit the famous Roadrunner and Coyote, and, well, really the Coyote. He's going to get launched off the side of a cliff, and this stuff is going to totally help us do those problems. Okay, so what we have here is we have v of t equals 5. So now we're given the velocity. Now, we did this with pictures, but we never did this with just algebra. And then it says, if s of 1 is 8, then find s. So, given the velocity, I want to find the position. Now, given the position, I can find the velocity by taking the derivative. So, given the velocity, I find the position by taking the antiderivative. So, this is what I'm trying to find. S of t. There's really a t to the 0 there. Some of you don't need to write that anymore. And so the antiderivative of 5 happens to be 5t. Then we have plus our constant. Now, lots of times we want to say, oh, okay, we found it, let's box it. But this right here is, this position function is kind of bad, because we're saying, where's the bug at time 1? And we put 1 in there. It says 5 plus c. Doesn't really tell us where the bug is. That's why we need this right here. This, let me go ahead and label it, is called an initial condition, and it's going to help us, or maybe a boundary condition, but it's going to help us figure out what the value of C is. So what does this really mean? It says S of 1 is 8. Let's go ahead and plug S of 1 in there. So T is 1. We don't know what C is, but we see that S of 1 is 8. So I'm going to set this thing equal to 8. So look what I have when I put that initial condition in. I have that equation that I can solve for C. This says 5 plus C equals 8. So C is going to equal 3. Perfect. So now I can go ahead and rewrite. This is a whole family. So sometimes, remember we saw all those parabolas? That was called a family of graphs. So this is a whole family, and now we're picking off one of the family members. So this is S of T equals 5t plus 3. And that is the position function. Oh, did we, you know what? Suppose the bug is moving on the, okay. So, I forgot to say, find, what am I trying to do? Find S, I guess. Oh wait, I have that right there. It says find S. I was thinking that I didn't ask us to find it, but there it is. There's the instructions, find S. We found S, and there it is. And you can actually plug 1 back in there. Look, S of 1 is 5 plus 3, which is 8. Now some teachers, and I'll do this sometimes they'll look at this initial condition and they'll say, time is 1 and S is 8. So if you had written this as S equals 5t plus C, you would put 8 in for S and 1 in for T, and you'd get the same results. So there it is. Let's go ahead and do a few more of these problems here. And this is what bug 12 is all about. This is what you're doing in bug 12. Okay, so we have a velocity function. We have an initial condition there. S of 2 is -9. Find S. Okay, so the first thing I'm going to do with the velocity is take the antiderivative. To take the antiderivative, I'm going to remember about the power rule. That's a t to the 1. So this is going to be 6t squared over 2. And then we have minus 10. The antiderivative of minus 10 is minus 10t. And then don't forget your plus c. Let's go ahead and clean that up a little. S of t is 3t squared minus 10t plus c. My initial condition is right here, and this is going to help me solve for c. So I'll go ahead and do it that other way now. You know, we have that time is 2, and the position is, or S is -9. You know, and so we could have, you know, like this is really S equals 3t squared minus 10t plus c, and then we put those values in there. So this is -9 equals 3t squared, so 2 squared minus 10 times 2 plus c. -9 equals, so that's 4 times 3, which is 12, minus 10 times 2, so 20. This is plus c. -9 equals 12 minus 20, so that looks like it's -8 plus c. And so you add 8 to both sides, c is going to equal -1. And so let's go ahead and write out the position function. S of t equals 3t squared minus 10t minus 1. That gives me the S, the position function that I was trying to find. Let's go ahead and do the last problem for this lecture for bug 12. And the last problem, they give you the acceleration. So you'll have a few of these in your homework. They give you the acceleration. And now we have v of -1 is 12. S of -1 is 0. Find not just S, but we're going to find v and s. So remember that the acceleration, so like you have the position, you take the derivative, you get the velocity. You take the derivative, you get the acceleration. Now, to go from the acceleration back, you take the antiderivative to get to the velocity. And then you have to take another antiderivative to get to the position. So let's start off by taking the antiderivative of the acceleration, or a of t. The antiderivative is v of t, which equals, okay, here it goes, 12t squared over 2. This is minus, let's go ahead and, I think I don't want a 12 there. I'm just noticing. There we go. Let's just turn that to a 2. We didn't really start doing anything on that anyway, so I'd rather have a 2 there, a -2 there, because I don't like two 12s there. You don't think that you're going to start doing this when you do your homework. Do the homework that's assigned, and on the tests, you do the problems that I put. So the antiderivative of 2 is 2t. So this is -2t, because there's a negative. And then I put a plus c. So the velocity function equals 6t squared minus 2t plus c. Okay. Now, I just went like this. I went back, and I'm sitting there, and before I go back again, I could go back again, but I think I'll find out what c is. How do I find out what c is? I use this condition right here. V of -1 is 12. Okay, so that says t is -1 and v is 12, and you've got this right here. V equals 6t squared minus 2t plus c. So let's plug these values right into there and see what happens. 12 equals 6 times -1 squared minus 2 times -1 plus c. 12 equals 6 plus 2 plus c. 12 equals 8 plus c. So c is going to equal 4. And so now we can rewrite this. So it looks like this. My velocity function is 6t squared minus 2t plus 4. I'm going to box it, because that's one of the things they asked. And they actually asked that one first, so that was kind of cool, because that's the first one we found. And we have used this initial condition here, where v of -1 is 12. And I suppose we're going to use this when we're going to find out what s is. So we're not done with the problem. We have to find out what s is. I'm going to go ahead and go like that. We have the velocity right there with a box around it. So s of t is going to equal the antiderivative of v of t. The antiderivative, let's go ahead and do the power rule here with these exponents. We have t cubed over 3 minus 2t squared over 2, and then we have plus 4t plus a constant. Now, some teachers would have an issue with writing this constant as c, because we already had something called c in this problem. So if I know what that c is and I replaced it with 4, I'm going to go ahead and use a c again. But for those of you who that would bug, I'm going to make this a blue c, which is different than that black c. Which, I don't even know if it would show up on YouTube as a blue c, but oh well, I'm going with this. So what is this? This is s of t equals 2t cubed minus t squared plus 4t plus c. So now we're going to go ahead and find out what, oh, this was supposed to be a blue c. What this blue c is, using what? What are we supposed to use? We are supposed to use this initial condition. So we're supposed to use s of -1 equals 0, because that was given to us. So this, I mean, you don't have to write this step, but it says this is really just s equals 2t cubed minus t squared plus 4t plus blue c. Okay, and I'm going to plug these values in. When t is -1, the position is 0. He's right at the origin on the number line. I'm going to plug this right into here. And when I do that, okay, so we don't need this. I'll move this up. I'll have 0 equals 2 times -1 cubed minus -1 squared plus, everywhere there's a t, I put a parenthesis with a -1. -1 plus, okay, blue c. Okay, let's continue. 0 equals -1 times -1 times -1 is -1. So this is -2, and then this is -1 times -1. Oh, be careful here. This is a pre-algebra student's nightmare right here. But hopefully you've done this enough. So this is -1 squared. That's a +1, and there's a negative in front of it. Then we have -4 plus c. So I have 0 equals, we add those up, that's like -7 plus c, which means 7 equals my blue c. Okay, so what am I going to do with the blue c? I'm going to go ahead and write out the position function. The position function is s of t equals 2t cubed minus t squared plus 4t, and then right there, plus 7. There it is. Now, we have that little diagram that I drew right here, and I'll kind of squeeze it in right there. When we first learn things, we learn derivatives. Think about it. If you had this position function, and then I gave you like some homework that said find the velocity function, find the acceleration function, that would be relatively simple. Now, knowing what you know how to take the derivative. You just zap it 2 times with your derivative gun. So that's why we learn derivatives first, because they are an easier concept. Now we are giving you the acceleration function, which was this guy right here, and we're asking you to find the velocity and the position. Sure, yeah, the antiderivative rules are not that bad, but because we have families of functions for our antiderivative, we also have to be given what? We have to be given initial conditions to find a specific position function and also a specific velocity function, which I have written on this page at the bottom that you can't see. So yeah, it's a little more difficult going from acceleration back to position than it is going from position to acceleration. But these are essential skills for, like, if you're going into physics or engineering, or you're going to be a math major. I mean, you should pretty much know all of this. But even in the business world, we have business calculus for a reason, because they use derivatives. They want to maximize their profits and minimize things. But you also have antiderivatives that will help them in the business world as well. So this finishes up Bug 12. The Bug 12 homework looks like that. There's 14 problems with the answers on the next page. I'll include both of these handouts in the PDFs. You guys take care of yourselves.